The time value of money. How if I have $1, if you give me $1 today or $1 from a year from now, would I be okay with either? Or is one better than the other? What would you rather have? $100 today or $100 a year from now?
$100 today.
Why?
Because just like how in the 1900s, you know, gas was 62 cents and now it's $3.
Okay.
It
Yep.
goes up.
$1 is worth more due to inflation reasons, which is what she's getting at. What else is better to have money today rather than a year from now? What could I do with that money? Invest it and earn interest. Right. Or I could, if I'm in a store, I'm in a business, I could use that $100 and buy more inventory and then sell it and make money that way. When if I didn't have the $100 for a year, I can't make any money that year. Okay, so there's different ways to invest. You don't necessarily have to invest in a stock market or a bond, which is what most people think of up front. What we're going to look at today with time value of money, and to kind of give you a little example, if I had $1,000 right now, and I wanted to invest it, say, in a something, because it's hard to invest $1,000, but we'll go with this. Invest it at a 10% rate for 3 years. How much will I have? Take a second and see if you can think through that one and tell me what you would get. And then I'm going to show us the long way. I'm not going to give you too long, 20 seconds or something. Then I'm going to go through the long way of how I would get this, and then a little bit shorter way. And we're going to begin, if you don't already have them out, go ahead and get out your charts. This is what I mean by charts. 38, 39, 40, and 41. These are time value of money charts. Typical Trent. You have to walk out to go get your pages. Can't wait till Ariana does it and I can catch. That'll never happen, right? Right. Okay, so how much would you have here? Give me an estimate. You'd have about what in 3 years? 1,300. Good estimate. Good estimate. Let's simply do this. This is just a little chart, 4 columns. So in year 1, I put $1,000 into the bank. And I earned 10% interest. Well, that should be pretty easy. It's I equals PRT. The time is a year, so that's just 1. 1,000 times 0.1 is $100. So at the end of the year, I have $1,100. Come year 2, money in the bank, I have $1,100. Interest, not 100 anymore, it's 110. %10 of how much I have now. This is called compounding interest. We've not dealt with anything compounding before. Compounding is when you earn interest off of interest. You're constantly updating your principal. When we had it the other way was called the simple interest way. And this is how student loans are. That's why they tell you, do you at least want to make your interest payments? Even though you're still a student, you can make your interest payments to help out. Because if you don't, what they're going to do on your student loans is say, oh, well, you had a $1,000 balance. Well, we charged you interest, so now your balance is $1,100. We're going to start charging you interest at $1,100. So now you owe $1,210. And then come year 3, you're charged interest on $1,210 instead of your original $1,000. So your interest continually rises. That would be the long way to do this one. There's a much shorter way. And that's where we're going to look at the first chart. The first chart, what I want you to remember on this one, number 38. Yeah, you'll want to keep them in order. It's going to be important to help you process which chart we're using until you get used to it. There's a whole big long title at the top. You can mark everything out, I don't care. The only key words that are really important here, future value and of $1. Future value tells me I don't know what this amount is. The future value, I need to figure it. And I'm going to help you when we're done with all the charts. I'm going to do a recap that tells you which chart to use in which situation. But this chart tells me, okay, future value. I don't know what this dollar amount is. I do know what it is now, present. That's easy, it's 1,000. I want to know the future value of that. I don't know this number. And the of $1, so this is the future value part of it. The of $1 is a lump sum. I just have one lump sum that I'm going to be issuing. One payment and that's it. No reoccurring payments. I have a one-time investment of whatever it is, and that's it. That's what the of $1 means, just one time, one amount. I want to know what is that one-time payment worth in the future. With your charts, the column that goes up and down there that says period, I'm going to refer to period as, and you'll see it later, as in. I can't remember why, but I don't know if it's from math or in is used. I don't remember.
It's from math.
It's from math, okay. In means period, and our period is how many interest compounds are there? How many interest compounds in total? And I'll make a little side note here. If when we do get to payments, we're not there yet, but when we do get to payments, every payment equals a compound. Just by definition, it will. in my example up here, how many times did I calculate interest during 1 year?
Once.
Just once. Yep. So then how many interests did I have in the entire thing?
3.
Just 3. Right. I had 1 interest per year. Now, that's by default. If I don't tell you otherwise, you invest 10% for 3 years, you assume annual compounding, which means you just do the interest one time, annual. I could tell you that this is semi-annual compounding. And that means we would do 1 for year 1, and we would have another, this would be like January through June, and then I would have year 1 again for the second part, because it's semi-annual. I'm going to do it twice. 1, 2, 3, 4, 5, 6 times for interest. But I didn't have it on this one. I didn't tell you that. So our N, number of total interest, how many times I'm calculating interest, is just 3. The other number you need is the interest amount. And your I is your given interest rate, whatever I give you, your given interest rate divided by number of interest compounds per year. Again, how many interest compounds did I have per year in my example?
1.
Just 1. So this one is really easy. The given interest rate of 10 divided by number of interest per compound was 1. So my answer is simply 10. Now, if I go to my chart, this is now where I can go to my charts. N is 3, so that's my period. I is 10. I get 1.331. So I take my known dollar amount, my lump sum, times the chart number, that's the short way of doing time value of money when you are calculating your compounding interest. I think that just blew Shelby away.
I did. I've used these little charts before, but I didn't remember how to use them, so.
Okay, let's look at it from reverse. What if I told you that at the end of 3 years, I wanted to have, I needed, let's say, $3,000. So I'm going to use everything the same that I had before to keep it as simple as possible. The only thing different is I know that in 3 years, I need $3,000. What I don't know, how much do I have to put in the bank right now at 10% interest to get me there? So you could think of this as like, I need a I want to save up for a house. And I want to put a down payment down or a car. And you're good and you're a very futuristic thinker. And I know I want to earn some interest, put my money to work. If I put down $2,000, would that be enough to get me to $3,000 in 3 years? It's not, but let's see how much exactly we need. Okay, the key is I can't use chart 1 anymore, the first chart that we did, because that was saying I want to know what the future value of some amount is. I already know what the future is, 3,000. I want to know what it's worth right now. So I need the present value. Chart 39. Yeah.
Okay, so this might sound silly, but I mean, because I got the charts right here and I kind of forgot that we had the present value, but I just took 3,000 divided by the 1.331 from the future. Would that get the same answer? Or?
Yeah.
Okay.
But this is going to allow us to always
Okay.
multiply.
All right, got it.
You're kind of, you could say,
I'm
oh man, do
backwards.
I forget? Do I multiply or do I divide?
All right,
And this one, you're always multiplying.
got it.
But you should be able to do it your way as well.
Okay.
Present value means I don't know what I need right now. I know what I need in the future. And of $1. I'm talking about one lump sum. I'm not talking about payments. Three periods. I is 10. $3,000 times 0.751. What's that equal? Is that what you got? Whoever was talking?
Yeah.
Is that what you got, Maria? Did I get
Yeah.
That way?
Yeah.
Now, we could work it out to prove that this works. Now, I'm not going to spend the time doing it. It's not wasted, but we need to keep going. But we can say, all right, let's check my work. Let's check this. If I have 2253 right now, I know the present amount, and I want to know what's it worth in 3 years, I can go back to the first chart. I now have a lump sum, and I don't know the future amount. So I look at the future value of a lump sum, 1.331. Now, it's not going to be exactly 3,000 when you do it. But due to rounding, because the chart numbers only go to 3 decimals. In reality, they go out much, much farther. So what I say is, if you have a rounding error for $1 per 1,000 that you're talking about, that's very acceptable. So when you do this, what are you going to get? Something 2997. I think that.
298.7.
Say it again. 2998.
Yeah, 0.7.
So I'm definitely, since I'm talking about $3,000, I'm less than $1. So I'm less than $3 off. That's a pretty good rounding amount. So what we've just talked about so far was lump sum. I know I said I do this at the end, but let's do a little comparison. And you'll definitely want to have some kind of a chart like this on your notes to go back, because it's to remember. Lump sum. First one's future value of $1. First thing that you have to use chart number 38, and when you come to homework or anything, I want you to refer to it as what it is, future value of $1. Don't tell me I use chart 38, because that's only, if you go to anybody else, they won't know what chart 38 is. but they do know what future value of a dollar is. I had a lump sum to deal with. That's my first requirement to know to use this chart. And I know the present value, PV. I know what the present value is, my lump sum amount. What I don't know is, what is it worth in the future? So the first chart we have, if you hit these two criteria, then you know what chart to use. Chart 39, present value of a dollar. First criteria is the same. We still need to talk about lump sum. The second criteria is where it's just a little different. I know what the future amount needed is. What I don't know is, what do I need now to get there? What is needed now to get to the future known amount? So that's the lump sum areas. The second part is the payments, which we are going to refer to as annuities. There are three requirements for something to be called an annuity. You can't just have random payments and that be considered an annuity. The first requirement is you have equal payments, equal payment amounts. So you always have $400. It's not $300 this month, $500 next month. It's always the same. The second one is, make sure I get the exact terminology I want to use. Same payment intervals. And that means monthly or yearly or weekly. It's always going to be the same. I make weekly payments and they come out of my check. Or I make monthly payments on a credit card bill. It's not sometimes weekly and sometimes monthly. It's always the same. And then it's at the same point in time in that interval. It's either at the beginning or the end of the interval. So I either make it at the beginning or the end of every month. Or the beginning or the end of every week, I make my payment. If you have those three requirements, then your payment system would be considered an annuity. And a lot of payment systems are. Like a mortgage, it would definitely be. Usually car payments are. Credit card payments may not be, because you always have different amounts coming in and out of a credit card payment. They very well could fluctuate and not be considered a true annuity. Okay, let's look at a real brief example, just like what we did up before. Instead of having $1,000 one time, we're going to assume now we have $1,000 end of year payments. With that said, I need to make a distinction here to show you, if you have payments due at the end of the month or the end of the year, whatever it is, it's called an ordinary annuity. Ordinary annuity. If your payments are due at the beginning, it's called an annuity due. We'll look at my little bit longer example, and then we'll do it the quick way using our charts. But I want to show you the long way first to see how it actually works. Year one. How much money do I have in the bank right now, day one? Nope. Zero, yeah. I put money in at the end of the year. So money in the bank right now, none. Zero interest. Money in the bank at the end of the year, now I have 1,000, right. So starting year two, I have $1,000 in the bank. Interest earned would be the $100.
2,100.
Very good. To get this amount here, I need to say, okay, I have my beginning amount plus my interest plus my new stuff. I put in a new $1,000 at the end of every year. So I have my old 1,000 plus the interest, plus the new money that I put in, my new payment. My interest, 10%, would be $210. So now I have 2,100. Plus 210, plus a new 1,000. So I have 3,310. In the bank. Let's look at that using the charts. Chart number 40. Key terms that you need to know on this chart. Future value, ordinary annuity. Future value, ordinary annuity. Well, we're going to keep, everything's been the same so far to help keep it a little easier. N is 3. I is 10, so I got 3.31. My $1,000 payment, my known amount, times 3.331. No, it's just 3.31. And it does again check with my long math that the chart works. Okay. How would this be different though if I said $1,000 beginning of the year payments. Beginning of the year payments. My chart isn't going to look like this anymore. This will now be 1,000. Everything's going to be kind of bunched up a little bit. How is that going to change my final amount? Do you think I'm going to have more in the bank at the end of the third year if I make beginning of the year, or more if I have end of the year? So I'll have, which one? Beginning of the year, will I have more or less if I make payments beginning? More. Mm-hmm.
Because you're investing it sooner.
Yeah, I'm investing it more. Yeah, I'm investing $1,000 now. This way, I didn't earn anything year one. This year, I am going to earn something year one. Let's see how much more it is. We're going to use the charts. But to be able to use your charts, this chart says Ordinary Annuity. We need to make a small tweak to our charts. We can still use this chart. We just got to make a tiny adjustment. And I would put this on your charts if I were you. Right at the bottom, so you don't forget. This would be considered an annuity due. If you have an annuity due on the future value side of it, whatever your N is, in this case it was 3, add 1. So whatever your N is, add 1 to that. So 4 would be our N. I, no change. Don't do anything to your I. Interest number. Whatever your number is on the chart, subtract 1. Now let's do this example. This is what it was, future value of the ordinary annuity. I want us to now know what the future value of the annuity due is. $1,000 payment times what?
Still the 10% interest, right?
Yep.
So it'd be the 1,000 times 10%, wouldn't it? No?
No, you got to look at the
Oh,
charts.
okay.
What's the N plus 1 is it? You're looking at the period 4, it's going to be 4.641.
Okay. But I'm not going to use
What do
4.641.
you mean number on chart?
That 4.641. That's the number that you find.
I said 3.341.
Right, 3.641. Subtract 1 from your number on the chart. So we definitely do get more money by investing earlier. What you would normally use, a good way to use future value of the annuity is for retirement. If I want to put money away, how much am I going to have at the end of whatever? Let me finish my little chart and then we may run out of time. So I had 38 and 39. Chart 40, future value of the ordinary annuity. That's our key terms on that one. A, you need to be dealing with payments. B, we want to know what is the future value of all payments together. What is the future value of all of those payments? Like your retirement, if you put $100 away every month for 20 years with interest, how much is all of that going to be in 20 years? We can determine that by using these charts, as long as you have a simplified interest rate, which we kind of have to guess. 41, your last chart. Present value of ordinary annuity. A, again, we're dealing with payments. B, I want to know what is the value of all future payments right now. What is the value of all of my future payments right now? This would be similar to saying you bought something, either I had 0 interest or I got cash off of my payment right now. Because if you're a company, think about this. If you offered me 0 interest and I could pay you $1,200 over 12 months, that'd be $100 a month. But instead of you giving me that option, you say you can have that option or you can pay me right now. Which one would you rather have? Would you rather me pay you $100 over the next 12 months or money right now?
Money right now.
Well, yeah, if I'm going to give you all of it, you would definitely want it right now. But would you be willing to take a little bit of a discount if I paid you right now instead of over 12 months? Would you accept $1,100 if I paid you right now? Or would you want $100 for the next 12 months? The lottery does this. They say you can win $10 million, or you can take cash payment right now of $5.5 million. Or we'll give you $10 million over 20 years. Which one do you want? That's called the present value of an annuity. Do you want the whole payment just spread out over time, or do you want to take a lump sum and invest that all for the next 20 years and maybe be at about the same place? That's when people give you you can have 0 interest or cash back on a purchase. That's why they do that. They give you a cash back option because they would rather you pay right now, even giving you a little bit of a discount. Okay, we're going to go through number 42 first thing on Tuesday.